Every day, electricity powers our lives. We flip switches, charge devices, light up our homes. I mean, it's woven into the very fabric of modern existence.
It really is.
But how often do we pause to truly understand the immense power at our fingertips, or maybe more importantly, the hidden dangers when things go, well, wrong?
That's a great question. We tend to take it for granted.
Exactly. So today we're taking a deep dive into one of those critical moments where electricity demands our full attention, the short circuit.
Or, as it's known in Korean, hey?
Right. It's not just some technical term. It's actually one of the most common and unfortunately one of the most dangerous electrical accidents that can
It
happen.
really is up there in terms of common household electrical issues.
So our mission for you today is pretty clear. We want to demystify what a short circuit is, why it's so incredibly dangerous, and maybe most importantly, how we can all work to prevent it.
Yeah, break it down.
We're going to break it all down from a beginner's perspective so you can feel truly informed and confident about this essential aspect of electrical safety.
Making it accessible.
Think of this as your essential guide, basically, to understanding a fundamental part of keeping yourself and your home safe.
Absolutely.
And to guide us through this important topic, we've pulled some fantastic insights from John Byung-Chul's excellent book, You Off Sale, which translates roughly to Beginner's First Steps in Electricity.
Published by Gilbert Publishing is a really good resource for this.
Yeah, it seems perfect for our deep dive today, explaining these, complex ideas in a really accessible way.
It is quite striking how something so fundamental, so everyday, can also be so complex and, well, vital to understand.
Right.
Many of us use electricity without ever truly considering the intricate paths it takes or, what happens when those paths are unexpectedly disrupted.
Totally. Often we only become aware when something stops working, or worse, when there's like a visible problem.
A spark or a smell, yeah.
That's so true. We take it for granted until there's a spark. So let's start right at the very beginning. What is a short circuit? Before we get into the danger, we probably need to understand how electricity is supposed to flow, right?
Precisely, yeah. Imagine an electrical circuit as like a carefully engineered highway for electricity.
Okay.
When a switch is open, think of a light switch in the off position. The air itself acts as an insulator. It creates a break in that highway.
So nothing flows.
No current can flow.
Uh-huh.
But when you close the switch, you complete the circuit, and the current flows along its designated path, doing its job like powering a light bulb.
Okay, so the electricity has its planned route, like a train on a track following a very specific path.
Exactly.
But then we talk about the short in a short circuit. Where does that name come from? What does it actually mean for electricity's journey?
Well, the term itself is quite descriptive, actually, or short circuit, refers to a situation where the electrical current finds a new unintended path that is shorter than its original designed route.
Shorter, okay.
This often happens when the insulation around a wire, that crucial protective coating, gets damaged somehow. Instead of flowing through all the intended components, the electricity essentially takes a shortcut.
So it's literally a shortcut. That actually makes perfect sense.
It does, yeah.
Our source uses a great analogy that I think really clarifies it for beginners. If you have a circuit connecting a power source to, say, a light bulb,
Right.
the current is supposed to flow through that bulb to light it up. But with a short circuit, what happens then?
Exactly. A short circuit would be like the current finding a completely new, shorter connection before it even reaches the bulb.
Bypassing it.
It takes an unauthorized detour, bypassing the intended load, like the bulb, entirely. That original, longer path of the electrical circuit has effectively been shortened, hence the English term short.
And that shortcut, that shorten the circuit, that's where the real danger starts, isn't it?
That's right.
Because if electricity isn't flowing where it's supposed to, what happens? Why is this such a serious problem, beyond just things not working?
This brings us to a really fundamental principle of electricity. In a normal circuit, devices like light bulbs, appliances, even just the length of the wire itself, offer what we call resistance or impedance.
Okay.
Think of them as speed bumps or maybe narrow lanes on our electrical highway. They help regulate the current.
Right. Keeps things under control.
Exactly. When a short circuit occurs, it bypasses these components. This new, shorter path drastically reduces that resistance and impedance.
So it's like suddenly removing all the speed bumps and traffic lights from that highway, allowing the traffic to just barrel through without any checks.
That's a very, very apt way to put it, yeah.
Yeah.
And when that resistance drops so dramatically, almost to nothing sometimes, we get a rapid and massive increase in electrical flow. This surge is what we call short-circuit current, or NO. It's a fundamental principle. Current flows less when resistance is high, and significantly more when resistance is low. If that resistance drops to nearly zero, which can happen in a bad short circuit,
Then the current just skyrockets.
becomes incredibly catastrophically large.
That sounds genuinely terrifying. What are the actual, tangible consequences of this huge surge of short circuit current beyond maybe just a tripped breaker? What could actually happen in our homes?
Well, the catastrophic consequences are precisely why short circuits are so dangerous. This immense current flowing through wires that just aren't designed for that kind of load.
Right.
It causes them to overheat severely. Copper wires, which make up most circuits, can get incredibly hot, often leading to fires.
Wow. Fires.
That's one of the most common and devastating outcomes. But, here's an important insight from the source. Many short circuits aren't always these immediate spectacular failures.
Oh.
Sometimes they're slow, insidious degradations. Insulation breaking down over years, silently increasing fire risk, maybe going unnoticed until it's far too late.
That's scary, too. The hidden danger.
Very. And even if a fire doesn't ignite immediately, the wires carrying this high short-circuit current are highly likely to be damaged internally or externally.
Right. They've been stressed way beyond their limits.
Exactly. The source really emphasizes that after an event like that, you absolutely must inspect the wires. You need to replace any damaged sections or reinforce affected areas before you restore power.
You can't just flip the breaker back on and hope for the best.
Definitely not. It's not something you can just ignore.
That's a critical point. The damage can be hidden, but still really serious,
Yeah.
affecting the long-term health of the whole electrical system. So, given how dangerous these can be, prevention has to be our absolute best defense.
Absolutely. Prevention is paramount. Yeah.
What are some proactive steps we can take, especially for us beginners? What should we be looking out for?
Because of their inherent danger, avoiding short circuits in the first place is truly the most effective strategy.
Okay. So, what should we be looking for in our daily lives, like with the devices we use every day?
Regular inspections are key. We should all try to get into the habit of routinely checking our electrical devices and equipment. Make sure they're in good condition.
Not just the appliance itself.
No, and especially focus on the wires and cables. Look for any signs of damage or aging things like frayed insulation, visible cracks, or sections that feel brittle or stiff.
Ah, okay.
These are all indicators that the protective layer is compromised and could potentially lead to a short.
Think about those old phone chargers you've had for years.
Guilty.
Or the tangle of wires behind your TV or computer. Are any of them showing signs of wear and tear?
That's a really great practical reminder. I know I'm definitely guilty of some serious cable tangles back there. So it's not just about what we see, though. What about what we might hear or even smell?
Yes. Our other senses can be powerful tools here, too.
How so?
The source highlights paying attention to unusual smells like a distinct burning odor, for instance.
Right, that plasticky burning smell.
Exactly. Or seeing sparks, obviously. Or hearing strange buzzing or popping sounds coming from outlets or circuits.
Okay. These aren't just minor annoyances. They're often early warning signs of an impending problem, like damaged insulation that could lead to a short circuit. Ignoring them is extremely risky.
Don't ignore the buzz or the smell.
Definitely not. And from a broader perspective, consistent preventative measures are just far more economical than dealing with the aftermath of an accident.
Makes sense.
Preventing an incident saves significantly more money, let alone stress, than the cost of restoring systems after a short circuit, not to mention the potential for injury or worse, loss of life.
That's a powerful motivator right there, saving money and potentially lives. But, even with the best prevention, electricity can be unpredictable and accidents can still happen.
Sure.
So what happens after a short circuit if one unfortunately occurs?
Right.
How do we mitigate the damage then?
This raises an important point about our safety nets. Even when we've done our best to prevent issues, electrical systems have built-in protective devices for those unexpected moments.
The backups.
We're talking about circuit breakers and fuses. These are absolutely crucial. Okay, yeah, we've all probably seen a fuse box or had a circuit breaker trip at some point. But how do they actually work to protect us from that massive short circuit current we were just discussing? What's the mechanism?
Well, it's actually quite elegant in its simplicity. A fuse contains a small, special wire inside.
Mm-hmm.
It's specifically designed to melt and break, the term used as yin or melt cut, when the current flowing through it exceeds a safe, predetermined level. That's its rated current, or DO.
So it sacrifices itself.
Exactly. When it melts, it physically breaks the circuit, stopping the flow of electricity and protecting the connected devices and, crucially, the wiring from harm.
Okay, and circuit breakers, they're reusable, right?
Yes, circuit breakers do a similar job, but they automatically trip or do, meaning open. They cut off the electrical supply when they detect an overcurrent. They don't usually destroy themselves.
So they just flip off.
Right. Both devices serve the same vital function: protect the electrical circuit from the damaging effects of excessive current, especially that high short circuit current. They are, like you said, the first responders of your electrical system.
Sacrificing themselves or cutting off power to prevent bigger damage down the line, that's incredibly important.
It really is.
And the source even mentions the idea of calculating this short circuit current in advance. Why is that necessary if we have these protective devices? It sounds, well, a bit advanced for a beginner like me.
You're right. It does sound complex, and it's not something you, as a homeowner or beginner, would typically do yourself.
Okay, good.
However, understanding why professionals do it is actually crucial for your safety.
Yeah.
When electricians design and install electrical systems, they perform circuit analysis to figure out, anticipate the potential magnitude of that fault current.
The maximum possible surge.
Exactly. Knowing this calculated value is absolutely essential for selecting and installing the correct capacity for those protective devices, the circuit breakers and fuses.
Ah, so they need to be rated correctly for the potential danger.
Precisely. Think of it this way. You wouldn't use a tiny, delicate padlock on a heavy-duty bank vault door, right?
No, of course not.
Similarly, you need to ensure your circuit breakers and fuses are robust enough, have the right rating, to effectively protect the circuit when an abnormally high current, like a short circuit current, flows.
So if the breaker isn't rated high enough,
Or rather, if it isn't designed to interrupt a current that high, even if it trips, the massive current might still cause damage, or the breaker itself could fail catastrophically. Without that calculation, you could inadvertently install a protective device that's too weak for the potential fault.
and it wouldn't do its job properly when you need it most.
Exactly. So while you don't need to do the math yourself, understanding that the math is done helps you appreciate why proper installation by qualified people using correctly rated equipment is so vital for your safety.
Wow, okay. So it's all connected, isn't it? From preventing the short yourself by checking wires to having these protective devices like breakers and fuses that can handle the sheer force if it happens.
Right.
And even the planning that goes into making sure those devices are chosen correctly in the first place. This deep dive has truly shown us that electricity is incredibly useful, but wow, it really demands our respect and understanding right from a beginner's perspective.
Exactly. It's about being informed and proactive, taking it seriously, rather than just being reactive when something goes wrong, especially when it comes to something as powerful as electricity in our own homes.
Yeah. So just to recap our journey today, we've explored what a short circuit, or truly is essentially a dangerous shortcut electricity takes when resistance suddenly drops.
Right. The path of least resistance, literally.
We've seen why this leads to that massive short circuit current causing severe overheating, fires, and potentially hidden wire damage.
Serious consequences.
And maybe most importantly, we've learned about the crucial role of prevention through regular inspections, checking those wires, using our senses.
Listening for buzzes, smelling for burning.
Exactly. And also the vital safety net provided by correctly rated fuses and circuit breakers.
The protectors.
So my final thought for you, our listener, is this. Armed with this beginner-level understanding, hopefully you're now much more aware of your electrical environment.
More mindful.
Yeah. The next time you see a stray wire or maybe smell something a bit unusual near an appliance or hear a strange buzz from an outlet, what will you do differently now?
Hopefully not ignore it.
Right. This knowledge isn't just academic, it's a really vital part of keeping yourself and your home safe. Stay curious, stay safe, and we'll see you on the next deep dive.